Right then, so now it's time to do the really fun part, which is to put the animated robot into some actual footage, so we get the result that we can see here. And the secret to getting this to work is, we need the 3D camera inside of Blender to perfectly match the rotation and movement of the camera that was used to film the footage. And thankfully Blender comes with some motion tracking tools which do exactly that. So let's head over to Blender. And once you've got Blender open, we're going to create a new file. So File, New, and we're going to choose VFX. So choose that, and it's going to open up Blender to the motion tracking workspace, which is where we get the camera to match the camera in the video footage. And very importantly, because in this scene we're eventually going to be doing some compositing, we need to make sure that we go to the render panel, right down to the bottom, we've got color management. So you need to make sure that you've got color management not set to filmic, you need to set it to standard, and look needs to be none, exposure 0, and gamma 1. This will just ensure that when we come to do all the compositing, we get the correct results. So we'll choose to save the file, just so it's got somewhere to put the cache. So choose to save. And before we bring in the video footage to the motion tracker, we actually need to convert it to a PNG image sequence, because the motion tracker will work much better with that format. So we'll go across to add a new workspace. We're going to add a video editing workspace, and then we're going to choose to bring in the footage that we've got. I'm just going to turn off seconds because I find that quite confusing. Now we've just got the frame range. So choose Add, Movie, and then you can bring in, just navigate to the folder location where your footage is. I'm going to start off with the Easy Track footage. And don't forget, if you're watching this on YouTube and not Udemy, and you want to follow along with the same files that I'm using, you can get them from the members area at 3d-illusions.co.uk. And that will also include all of the completed scene files and assets for the course as well. I'll also put the link to that in the description below. And we'll drop this in, but make sure before you do this that you set use through movie frame rate. So use these options so that basically when the frame rate over here, as soon as this footage is brought in, will be changed to match the movie footage, which is important so that we get the right number of images. So add movie. And we can see that we've got the footage and it's coming upside down, and that's because I'm using an Apple phone apparently. So I need to change that. If this happens to you, I'm going to show you how to fix that in a second. But before we do that, we just want to get the frame range to match the movie frame range. So under View, choose Range, and then choose Set Frame Range to Strips. And just make double sure that the frame rate has changed to match the movie frame rate as well. Right, so now I've made sure that the frame rate matches up and we've got the correct frame range. I'm actually going to delete this now, and I'm going to convert that footage using a third-party application so that when it gets re-rendered, it will then import correctly into Blender. You can use any application you want, like DaVinci Resolve or Adobe Premiere, anything that can render or re-render a movie file. So I'm going to use the free software, which is Handbrake. So I'd recommend, if you don't have any of the others, just download Handbrake. It's free of charge. And once you've opened that, all you do, you drag the footage in that's coming in upside down. You set the location that you want it to output to. And then you just click on the Start Encode. You can change the format if you want to, but MP4 should be fine. Okay, once you've got that, you can bring your footage back in. So if you drag it back in now, the converted footage, and you need to make sure it's on frame 1, so I'm just going to click on them individually and press Shift S, and that'll put them back to the current frame on the timeline. So just make sure you're on frame 1 first before you do that. And now you can see the footage has come in the correct way around, and we're good to go. So what we need to do now is output this as a PNG image sequence. So in the output properties over here, you just scroll down a little bit. We'll change the location to be // so that it saves the PNG sequence to the same folder that the blend file is in. And I'm going to change this to Easy Track Sequence. This will create the folder and then the name of the file. So I'll just call it Easy Track. Okay, and then make sure it's PNG. We don't need RGBA because it's only RGB in this case, because the footage doesn't have an alpha channel. And once that's done, we can just go to render the animation. So Control F12 will render the animation. Or if you're using the Turbo Tools add-on, like me, then you can press the Control Alt F12, because we don't want that turbo cache to get generated. And now we've got the PNG sequence saved out, we can get rid of this video footage. So delete that, and then we can go back across to the motion tracker. I'll just close this workspace, we don't need this one anymore. So back to the motion tracker, and now we can bring in that image sequence. So we'll go open. We've got easy track sequence here. And I'll just select all of them. So press A to select them all. It's very important, by the way, that these are listed in the order that you want them to come in. If they're listed in reverse, like this for example, then they're going to come in reverse order into the motion tracker. So just make sure, click on name so that they're in the correct order, and then choose open clip. And that will bring them in. And to make it a little bit faster to play back, click on prefetch, and this will put that image sequence into system memory, and then you'll get much faster playback. So the tracking system is actually very simple to understand. All you do is place little tracking markers, like by control left clicking for example, in various places in your scene, a good distance away from each other, and never on anything that's moving, like branches for example. And what will happen then is, Blender will try to stick these little markers to the same position on each frame. And it will do that, if we just zoom in, I'll come over to the clip display, make sure we've got the search area turned on. If we click on one of these trackers, we can see we've got a little area inside, which is the pattern area. Come across to the track panel over here, we can see that more clearly over there. And it will try and find this same pattern on every frame and then move the marker onto that pattern, which will make it stick to it. The search area, the outside area, is the space in which it can look for that pattern. So if you've got really fast moving footage where the pattern on one frame is here, but on the next frame it's over there, then obviously this area here is beyond this search pattern, so it's not going to find it and it's going to fail, in which case you'd need to increase the search area before you did the calculation. Alright, so that's the first way you can add the trackers, by control left clicking. The second way you can add them is by using the detect features option over here. So if I just delete all of these trackers now, I'm going to make sure I'm on frame 1, so shift left arrow and go back to frame 1. We can place the trackers automatically using this, so detect features, and it's going to place trackers everywhere. Now obviously this is problematic because it's going to put them on all these moving objects like leaves and branches and maybe flowers that are blowing around in the wind. What we need to do is tell it a way to only put it in specific areas where we know there's no movement. So we can come to the annotation section and just choose draw, and draw around the areas where you know there might be movement. So I don't really want this grass. I'm going to draw around there, make sure I close that off, and I'll choose draw again. And I don't want the tree either, so I'm going to, or the branches rather. So I'm going to select all this area where we might get wind affecting the leaves, and just close that off as well. And now if I choose detect features, so I come to track, detect features, and then I can press the F9 or open up this menu down here and choose only outside the annotated area. And then it's going to make sure that all these moving parts are excluded. And quite simply from this point on, all we do is track all these through the entire footage using the buttons at the bottom there. So we've got the track forward by 1 frame, track forward until there's a problem, and then we've got these buttons here. This will get rid of any tracking information after the current frame, wherever your timeline might be. So say if you have problems with one tracker, you can select it and then remove the tracking data after that and then try and fix it. And the same on this side, 1 frame backwards, track backwards until there's an issue, and clear the markers as well. The refined ones I never use. They don't really seem to work, so I'm not going to try and explain those. So what we do, we're going to track forward until it fails. And I can hide these now, so let's go to view and we'll delete that. Don't really want that. We'll press E and track markers forward. So E is the shortcut for these down here. You've got all these different options. I don't want to see the disabled ones, so I'm going to come across here and make sure I turn show disabled off, just so I can more easily see what's happening. And then make sure you've got the trackers selected that you want to track, and track markers forward, and it will track forward so that you can watch what's happening. Now the problem is, by default, Blender is set in the track options here. If we come down to just choose one of these trackers, so this one, shift click on it, come down to the bottom here. Under the tracking settings, we've got this tracking settings extras, and under there we've got speed. So by default it's set to fastest, which means when you track this forward, it's just going to fly through and you're not really going to get a chance to spot any problems that might have happened. So I'd always recommend put this to real time, and then when you track forward, so E, track markers forward, you'll be able to watch it happening. So you can cancel it with escape. I'm going to go full screen so we can zoom in and get a better look. About there, and E, track markers forward. I'm just keeping an eye to make sure nothing goes haywire and little trackers start sort of staying put, so they're sliding in place rather than following the footage. And as soon as you see a problem like that, you can press escape and then fix or delete that tracker. As long as you've got more than 8 trackers or more rather on each frame, then that's sufficient to do a decent job. So I'm just watching this now, making sure everything sticks in place, and if it doesn't, I'm going to escape to stop it temporarily and then delete it. But this seems to be doing a really good job, although press escape, I think I did just see a problem over on this side. So you can see this tracker over here. As soon as we get to this frame, it slides this way. So we don't need to delete the entire tracker. What we can do, the last point it was good, I'm going to select it, press E, and I want to clear this tracker's data forward. So if we just come over here, you can see we've got this graph. This is showing the data for every single tracker in the scene. If we just zoom out a little bit, this represents each tracker's X and Y movement that it has to make in order to stay stuck to that position of the movie. So you can see here, this is that rogue tracker. So we could actually come forward to this point, and we'll click on this to select that tracker, which is already selected. So it's already, if you click on it though, if it's not selected, it will select it over here. I just want to clear forwards because all this tracking data backwards is perfectly fine. It's all usable. The thing you're looking for is that all the trackers follow a similar pattern. It doesn't have to be exact, because obviously trackers that are further away in the view will be moving a little bit differently to those that are close to the camera. But as long as it's reasonably similar sort of pattern, if you zoom out like this, it's easier to see, then you should be good. And there's an obvious example of where it's not. All I'm going to do with this tracker selected is choose this button here, clear track path forward. I'll do it in full screen. And that will delete all of the data for that tracker forward of the timeline. And then we'll come back out of here. We'll select all the trackers, apart from this one. Make sure you don't select that one. So I'll actually lock it now, so it doesn't accidentally get selected. So choose Control L, and that's locked that tracker now, so that it won't track any further. And then I'll press deselect it, press A to select all the others, E, track markers forward, and now that one's not going to track because we've locked it. Let's just escape and go full screen. And E, track markers forward, and now I'm continuing to watch any similar problems to that, where trackers start behaving in a way that they're not sticking to the footage. And we can see a bird just popped in there. That may disturb this tracker. We'll have to see at the end. Alright, so that's finished. Let's come back into full view and we'll have a quick look at the graph and see if there's any obvious problems that are jumping out at us. So that looks pretty good. There's nothing really quite badly out of sync with the overall flow of the pattern. So it should be quite good. From this point, quite simply, all you need to do is in the track panel, come down to the camera section and just put in the specifications for your camera's sensor width and the focal length. You've got these little presets here where you can look for your camera. Mine's an iPhone 6s Plus, so I've made a preset already. Once you've entered your details, you can save the details by just coming down to the bottom here, typing in the name of your camera and clicking plus, and that'll put it in there for future use. So 6S plus for me. And these are the settings if you want to copy them. You can put the optical center and lens distortion back to 0. So let's go across to the solve panel, and basically the solving is where it calculates the movement of all the trackers that you've placed, and it tries to figure out, based on that movement, whereabouts in 3D space they are. And in order to give it a fighting chance at doing a good job, we've got to specify a few things. So the keyframes are used to indicate a start and end frame where there's a big perspective change in the video. And if you're not sure where that is, you can just click this keyframe option and Blender will try and find that for you. So once you've done that, we can also have it automatically improve the focal length based on what you've got in there. So I'm going to tick this. And then the optical center and radial distortion will try and change these settings over here so that any distortion in your camera is automatically detected and then updated over here to give you the best possible result. So with these two ticked as well, I'm going to choose solve camera, and it should be, hopefully, a decent result because everything seems to be staying in place and we've got plenty more than 8 trackers on every single frame. The only thing that does bother me a little bit is that we've got trackers on these branches of this hedge, which may be having a little bit of movement, and also they're quite close together. So the closer your trackers are together, any sort of slight pixel inaccuracy during the track will be amplified. But we'll give it a try and see what happens. So it's trying to find the point of the video where there's the biggest perspective change so that it can set keyframe A and keyframe B. So as soon as you start using the solving tools, you're going to start getting errors most likely, and the errors are going to mean nothing whatsoever. So they're not very intuitive, they're not very informative error messages that Blender gives you. It'll just give you some errors at the bottom, maybe something about a bundle, or it can't reconstruct data, or you'll get something about your NAN up at the top here. And it might say, check out the system console for more details. You go to the system console and you'll get messages that are things like point behind camera intersect CC159 or something about a Levenberg marquee, whatever that might mean. .H144 failed to solve. It's not going to give you any useful information. So at this point, I thought it's worth mentioning that any problem you're going to get whilst tracking, any error, no matter what it is going to be caused by one of 3 problems. So the 3 problems are, firstly, insufficient number of trackers. The second one is that the trackers, you've got sufficient trackers, but they're sliding all over the place. They're not sticking to the pattern very well, so it can't solve them. And the third one is you've not set the camera up properly in the tracking panel over here. So you just need to make sure you put your correct camera settings in there. So the first problem is easy to detect. You don't need to sort of manually go through and check and count if you've got more than 8 trackers. So 8 trackers is the minimum that you need in order to get a decent track. So instead of going through and counting how many trackers you've got, you can just go to the dope sheet at the top here. If it's red, you've got a red area. It means you've got less than 8. If it's brown, it means you've got less than 16, but more than 8, so you might be okay. If it's grey, it means you've got more than 16, so providing the trackers aren't sliding around, you're going to probably get a decent result. And there is another scenario where you've got insufficient data that doesn't show up in the dope sheet, and that's if you've got a gap. So to find those, you'll need to look in the graph editor at the bottom. For example, just here. So even though if we go to frame 110 here, we've got more than 8 trackers on the screen. We go to the next frame, we've still got more than 8, but there's a disconnect. None of these connect to each other. So that is going to cause a problem as well. Not necessarily, well, possibly when you solve, if your keyframe A and B, either side of this gap, you're going to get an error. Let me just show you. So 108 to, let's say, 114. So we're going from here to here, setting that as the keyframe A and B, where it's going to try and base its perspective calculation on. If I try and do a solve here, we're going to get an error. At least 8 common tracks on both keyframes are needed. So it's saying that between keyframe A and keyframe B, you've got a gap, basically. And having a gap can also cause an error message when you try and use the orientation tools on the 3D scene. For example, I might want to use 3 trackers to indicate where the floor should be in the 3D world. So I could say, use these trackers as the floor position for the 3D scene, and we're going to get a different error message that means exactly the same thing. 3 tracks with bundles are needed to orient the floor. So again, all that's saying is you've got a gap in your data, or there are some frames that don't have 8 trackers. And both of these problems are easy to fix. Basically, we can just go either side of the gap, maybe 2 frames. We'll choose the trackers and we can track forwards to fill the gap in, or we can come this side, choose all these ones and track backwards. So Alt left arrow to manually track 1 frame at a time. And that'll fill the gap in and you should be okay there. And to fix these problems with insufficient or not, you've got less than 8 trackers, you can come to this point and very simply, you can just add some more trackers. So let's say I go to maybe here, we'll find a point that's not too blurry. We'll create some more trackers and then I'll track these backwards. And if you'll watch this area, the red will disappear. So E, track markers backwards. You see the red has disappeared and that should give us a better result, providing, of course, those trackers are of a decent quality and aren't sliding around. We'll cover this more later as we go through the course. So on to the second cause where you've got enough trackers, but the data is not very good. And you can spot this quite easily just by looking for any trackers that are deviating quite wildly from the overall general pattern. As you can see with this big green one here dipping down, that indicates that the tracker that line represents is sort of sliding all over the place. We'll look at how to fix these as we go through the rest of the course. So for me, it has worked with a result of 3.2, but that's not very good. The solve error that ideally you want to get is below 0.3 pixels. The higher the solve error, the more the 3D geometry is going to appear to slide around on the footage. And what we can do to find the problematic trackers is come across to the dope sheet, make sure it's sorted by average error, and then at the top you'll see we've got a few trackers which have got quite high error rate. So the error rate is here. This is the average error, solve error, for this particular tracker over the entire range of the movie. So we can select these by, make sure you deselect them all first in the viewport by clicking anywhere, and then we'll just select the problematic ones at the top and we'll delete them. So X and delete, and then I'll try and solve again. And now we've got a solve error just by getting rid of those ones that have got a really high solve average or solve error average. By deleting those, we've now got a solve error overall of 0.21, which is incredible. So that's a really good result. And it's not surprising because this footage was so easy that all the trackers stuck in place pretty well. So now what we need to do is apply this solved data to the 3D scene. So quite simply, we'll come down in this panel to the solve panel and we'll choose Setup Tracking Scene. That automatically adds the background to the camera. So we click on the camera, come to the camera properties. We've now got under the background images, we've got this set up. So it's showing in the camera view. And it's created the plane and a cube for us as well. We can delete these. I find it's easier to work with a torus to see if it's sticking properly to the ground. So I'll delete those. Shift A, I'm going to add a torus. So that's going to put the torus to the middle of the screen, to the origin. And let's just bring up the properties so we can have a look at the details of this. So the torus is 2.5 meters wide. I think the path is probably around about 1.5. So I'm going to change this scale to be about 1 meter. So I'll just scale that down until it's about 1 meter on the right. And then we'll choose to apply the scale, Control A, and apply the scale. Right. Now obviously at the moment, just expand this a little bit, the grid is not correctly placed on the floor. So we need to fix that. So come back out of full screen. Let's come across to this area. And we need to find some trackers now that are on the ground that create sort of a triangle. We need to make sure we select them on a flat part. If we select 2 here and 1 down here, it's going downhill. So the angle will be incorrect over here. We'll have a sort of a downhill slant on the 3D view. So select 2 that are quite close together, or 3 rather. So this one, shift click this one. Be careful you don't click on it and move it. You can just click just outside of the tracker. And I'll choose this one as well. So we've got 3 trackers now, and this one the last one we selected is going to be the origin, so the origin of the 3D viewport. And I click on floor, it's going to move those down, and we can see if we just zoom out, it's modified the position of the camera and the trackers so that they align with the 3D world in order to make the torus appear to be sat on the actual floor of the footage. Now, it's quite possible, but when you tried the set floor button, things didn't go quite as well. And I've just found the same actually as I'm going through this tutorial to make sure everything's still compatible with Blender 4.1. So I'm going to show you the issue I ran into and how to fix it. So basically, when I click floor, instead of the result I got before, the donut shrank down to almost an invisible state and the ground plane was completely incorrectly orientated. So I'm going to show you how to fix these two issues. Firstly, we're going to choose which tracker we would like to be at the world origin. We'll click on this one and I'll choose set origin. You can see it's moved the origin over there. And now I need to make sure that the camera is scaled in a way so that the 3D world appears scaled to match the footage. So I'm going to choose two trackers that I know the distance between in real life. Approximately, I've not actually measured them, but it's about 1 meter. So I'll go to the solve panel, under orientation, I'll set the distance to 1 for 1 meter, and I'll just click on set scale. As soon as I click that, you'll see the donut is now scaled correctly. And it's done that by, if we just come out, I'll choose the camera, you'll see it scaled the camera down to achieve that correct result. The next thing I want to do, I want to orientate the X or the Y axis to be pointing along the path. So the origin, if you remember, is this one here. And by the way, we can actually, if I come over here, let's just turn up these empties a bit so we can see them. So I'm going to go under overlays, under plane axis, and turn those up a bit. Now we can see them in the viewport. And we can see that the one that I've selected in here is now selected in the 3D viewport as well. And then we can do that with any of them or multiple, like so. And we can also select them in the 3D viewport to select them in the tracker. All right, so this one is the origin. And now I want to align the X or the Y axis to point along the path. And to do that, I need to choose one tracker whose direction from the origin tracker is the direction I want the world axis to point along. Set the axis. I'm going to set that as the Y axis. And now you'll notice that the Y axis is now aligned between the origin and the tracker that I chose. Let's play this back. So the result is really good, but I think the donut is pointing downhill very slightly. The reason for this is that the path itself in real life is not completely flat. So when I use the options over here to set the floor, it's just orientated that floor a little bit incorrectly. So we can fix that manually. So I'll create a new workspace. I'll set this one to be the 3D viewport. Let's just turn up these empties again. I've got the camera selected over here. If I move the camera, it's going to move all of those empties or rotate it. It's going to rotate them. We need to make sure we only move or rotate the camera around the origin point to maintain the correct result. So we're going to change this pivot point to be the 3D cursor. And we need to make sure, of course, the 3D cursor is at the world origin. So Shift C. And now we can rotate just the camera and the empties. Let's go into side view. And then we can rotate the camera on in this case, the X-axis until the donut appears to be sitting more correctly on the ground. And if we want to, we can rotate on the Y-axis if necessary as well. So RY, we can rotate that a little bit as well. And then lastly, of course, in order to not get the effect of the 3D geometry sliding around, we need to make sure that it's perfectly on the floor. So GZ, we'll bring that torus up so it's sat perfectly on the floor, and now we should get a perfect result. Now, you might run into a situation where no matter what you do, you can't get a decent result. And this is usually because in the motion tracking, even though you've had a decent solver error, the camera settings in the track panel, particularly the sensor width, pixel aspect and focal length, were incorrect. So you might still get a decent result, but if you're using incorrect camera settings, it can result in the markers just being placed completely incorrectly, and it's impossible to orientate it correctly in the 3D viewport. So in that scenario, just check your camera settings and then re-solve afterwards, initially with these options off, the refine options, and try a manual keyframe A and B. And if you get a reasonable result, then you can turn these refine options on and see if it improves the solve error a little bit. And then you don't need to reset up the viewport. You can then just go back down here and just go through the procedure of setting the floor, the origin, and the scale again, and the y-axis. So this time, moving on to the fast shutter version, I've already gone to the trouble of converting it to a PNG sequence because you don't need to see that again. We can probably take a very similar approach that we took previously because the footage is in such good condition, there's not really much motion blur. But there is in the scene a very fast area of movement. So because of this, there's quite a high possibility that if we stick with the default settings, the search area won't be big enough. So in the tracking area, these are the settings that apply to new trackers. So whatever you set in here is what the new tracker will use. And then on the right-hand side, you can then modify these settings for the actual tracker that you've got selected, or multiple trackers if you've got them all selected. So instead of using the defaults, because of this fast movement here, I'm actually going to choose the preset of fast motion. And that will make the search area a little bit bigger than the default. So when it was default, it was set to a pattern size of 21 and a search size of 71. But where we choose the fast motion, it will increase the pattern size a little bit, but more importantly, it will increase the search size so that it's got a much wider area to search for. It will slow things down a little bit, but it will be necessary most likely. Underneath this, we've got the motion model. So the motion model gives you various options that tells the tracking algorithm how the pattern might be changing so that it can more easily recognize it. So say for example, currently we're using the location and rotation. So it's only going to check for the pattern, well, it's going to be able to tell if it's the same pattern if the pattern moves location, but also if it rotates. Because we're getting quite a big perspective change here, from here across to here, then the pattern's perspective is also going to be changing. So it might be a good idea to change new markers to use the perspective model instead, so that when the perspective changes, it can still recognize the pattern. The affine is one we're going to come to in the next part of the tutorial, where we look at that really bad nightmare footage, but we'll come to that later. Just to give you an idea what that does, if the pattern changes shape, which it will when there's motion blur because it will become stretched out, then the affine will give it a better chance of being able to spot whether or not it's the same pattern or not. But perspective should be fine for this one, because I filmed it on such a high shutter speed that you'll see that when we change frames, we're still getting identifiable patterns. There's no stretching going on, just because of that high shutter speed. So this should be really easy to track as well. So the same as before, I'll go back to the first frame for the animation. I'm going to use the annotation tools to draw the parts of the image that I don't want to be tracked. Now, actually, looking at this footage, if I just zoom in and play this back, you'll see it's a perfectly still day. There's actually no wind whatsoever. Yeah, it seems to be completely still. There's no movement on these branches or leaves. So I think we can actually get away with actually not using the annotation tool. So I'm going to give that a try. Let's go back to frame 1. I'm just going to choose Detect Features. And if you get too close to the edge, sometimes that can cause problems. So I'm actually going to press F9. And I'm going to change the margin a little bit. So increase that margin, and that will get rid of them really close to the edge. And again, if they're too close together, you can change the distance between them, the allowable distance. If I increase this, we'll get a bit more of a distance between them, which might help with the accuracy as well. And the threshold, I generally leave at 0.5, but if you turn it up, then it might get rid of a few that the quality of the pattern isn't really that good. So I'll put it up a little bit, and we still get generally the same amount of trackers. So what I'm going to do now is track forward, make sure I'm on frame 1, E, track markers forward. And again, I'm just looking out for problematic places, and we can see if we just go back to frame 1, I'm going to turn off show disabled so that we can't be distracted by the red ones. Let's play this back. And we can see actually this one here is actually behaving quite strangely. So I'm going to delete that one. Let's just have a check for anything else that might be looking a bit weird. And you can see the shape of these now is changing based on the perspective. So it's not stretching, it's just changing the pattern shape based on the perspective of the video. And that's giving it a much better chance to continue recognizing that pattern as it works through the frames. So we'll continue to track forward, we'll select all the markers, E, track forward, and just keeping an eye out, make sure there's nothing weird happening. And when you lose too many markers, when you've got less than 8 on the frame, so we're okay at the moment, but when we get to here, we just press escape, and we'll go back a few frames. You can see we've only got 3, 4, 5, 6, 7, 8, 9, probably to about here. We've lost too many markers, so we're not going to be able to track beyond this point very accurately. So I'll just come to maybe about here, and I want to add some more trackers, but I've got to be careful that I don't get these trackers too close together. So if I just choose detect features now, it's going to add trackers everywhere, even if there's patterns that are already being tracked. So I'll just undo that. It's very important not to do that. So I'm just going to come to this point, and I'm going to use the annotation tool. So draw, and I'll just choose this area. I'm going to detect features again, and just press the E menu, press detect features, and then F9, and I'll say outside the annotated area only. So now we've not added any more trackers in the area where we've already got them. We'll get rid of that now. Select all the trackers, including the ones here, and we'll E, track markers forward again. Just keeping an eye out again. We've got a really strange one there. This one is flying across the screen. So we'll come back to the point where it's sticking. So we've got a weird one down here as well. But we'll take care of this one first. So at this point, it goes weird. So I'm just going to, with it selected, we'll navigate to the little graph. So we'll expand this. We can see we've got a marker going a bit haywire. So if I just deselect that and then choose this one, probably these ones are a bit weird as well. So I'll look at those as well. I'll come to the point where it went wrong. I'll just choose to clear forward. We don't need to get rid of all the data because that's useful information. And I'll choose this one as well, where that's obviously deviating from the overall pattern. And I'll clear this one forward. And then at this point here, let's just select these as well. And let's have a look what's happening there. So over here, we can see we've definitely got a weird pattern again. I come to this point. You can do it in the 3D viewport if you want, and I'll clear forward. And this one as well is going weird. I'll come back a few frames where it's planted nicely. Clear that one forward as well. Make sure we choose the right one, this one. Clear that forward. And then lastly, this one's going weird. So about here, we'll clear that one forward. And also this one I can see has got a line going upwards. So we'll come forward a few frames. And I'll clear forward from there. So everything else, just come across here now, is looking quite smooth. Maybe this one. Let's go back and find where that one's on this frame here. Got a slight deviation. So I'm going to clear that one forward as well from there. If we come back now, we should have a reasonably good looking result. Don't worry about these ones. If they start off like that, that's just where the new tracker started. So that's nothing to worry about. Actually, this one goes down at the end as well. Let's just come and see which one that is. Might be okay, but I'll just to be safe, we'll clear that forward as well. So we can see now at this point, we've not got anywhere near enough trackers on the screen. What I'm going to do instead is go to the end now and choose detect trackers on this scene, and then we can track backwards. Now you've got to be careful, obviously, if you've got moving cars and things, like there's a few cars over there, you want to exclude those. So I'm going to go to the annotation section, and we'll draw around these cars. And we'll probably, in fact, let's draw around the entire, let's just delete that. We'll draw around the entire road, just in case the cars come into this area, which will break the trackers as well. And the traffic lights will change colour, so we'll just put those in the area we don't want. Then we'll do E, detect features, and it's automatically going to retain the same settings we used last time. So it's just outside there. Now actually, I'm going to undo that. Previously, we had to do some cleaning up because the trackers were becoming a little bit unstable towards the edge of the screen. So I'm going to go to the tracking settings, and then under tracking settings extra, I want to tell it to stop tracking within a certain margin from the end of the screen. So I'll set the margin to something like 100 pixels. The correlation's fine at 0.6. That's just telling you, that tells the tracker how sure has it got to be before it decides to disable the tracker. So currently it's got to be 60% sure. So we'll leave it at that. We can always find errors afterwards. And we'll come to the end of the track again, the end of the screen, and we'll choose E, detect features. And now we'll track, this time, track markers backwards. So E, track markers backwards. And they've managed to get back to this point here, so let's just have a quick playthrough. And we've always got 8 trackers on screen at any one point. We can see there we've got way more than 8. And here, we've got way more than 8 as well. So we might be okay. We'll give that a try. So come across to the solving panel again, go down to the track, make sure we've got the camera settings set up properly, which I haven't, so I'm going to choose this, preset of iPhone. I'll set it to automatically find the best keyframe, so choose this one, and focal length as well. Go back to frame 1, and I'm just going to solve the camera motion, see how we do. So it's not too bad, we've got 6.78, but it's still quite high. And we can see if we go across to the dope sheet over here, at the very top we've got one that's got 191 average pixel error, which is massive, and that's probably affecting all the others. So we'll choose this one. Let's just make sure we've got no other ones selected. Choose that one, and then we'll go to the end where that one becomes visible. So it should be visible here, because we can see in the dope sheet it's there, and there it is. So I'm just going to, let's just have a look if we can actually see a problem with it. It could be that there is a slight bit of wind perhaps, I'm not sure. I mean, it looks fine. Just seems to be fine, but we'll get rid of it. And then we'll try tracking again. And it's taking the arrow down a little bit, so we're going to try and get rid of a few more of these. Get rid of the top 3, I'll delete those and try again. And that's actually made it worse, so let's not do that. Let's just try these options. And that's made it worse as well, oddly. That's not really making much sense. We've not changed anything. We're getting a different. Oh, we're changing the keyframe. So let's just try again. Solve camera. Let's see if these keyframes change each time we solve it. So they're now staying set. And what I'm going to have to do is try and override these now. So I'm going to do it manually to set the keyframe. So there's quite a bit of movement. There's not many trackers in this part actually, so it might help just to add a few more trackers. So I'm going to zoom out a bit. Let's see when all those trackers disappeared. So around about here, we start losing a lot of trackers. So I'm actually just going to manually stick some trackers in there. Making sure not to put them too close together. I'll choose them all and I'll track forward again. And you'll notice as it tracks forward, the dope sheet background at the top left is changing from brown to grey. And that indicates that they've got more than 16 trackers on those frames. So it might be a good idea just to go before that brown area, or after it rather, and then we'll select the markers here and we'll track these backwards so that it overwrites that brown area going backwards, so that we've always got more than 16 tracks, more than 16 track markers on the screen during that period as well. And I'll choose to keyframe. I'm going to set all these options again and choose to solve the camera motion, see if that helps. So it got us down to 7.23, but we're still getting a big problem, which appears to be right at the end there. In fact, hang on, let's have a look. Got a bit of a problem on this one. Let's see where that is. There's that one there, we can see is sliding dramatically. And how long is that on screen? So it's on screen from there. So it's actually doing a good job from this point, but from here, it goes all bonkers. I'm going to clear that one this time backwards. And that will get rid of this area here. So clear backwards. Then we'll try solve camera. So we've got us down to 0.91. And I suspect we've still got a problem at the end. Not too bad actually. So before I start messing about in the 3D scene, I'll just make these markers a little bit smaller, these tracking markers, so we can see what we're doing. And although we've got the 3D scene already set up from the previous example, we don't yet have the background set on the camera in the 3D viewport. So we can either click on set as background and use the existing empties, or we can just click on setup tracking scene, which will create it again from new. Either's fine. So I'll just delete the plane and the cube, if it's got one. Where's the cube? I'll create a cube this time, feeling a bit stingy. And then we'll do the same as before. We'll choose 3 markers that are in a triangular formation. So around about here we've got 3 markers. I'll choose this one, and this one. And I'll say set floor. I should move everything onto the floor there. And then we'll choose this one, and this one. And I'll say, I'm thinking that's probably around about 1.5 meters. I'll change this time to 1.5 and say set scale. And that's worked pretty well. Let's put the donut down there. And now I need to set the origin wherever I want the donut, because the donut is at the world origin. Currently it's on this one. We should be fine, so I'll leave that where it is. And I'm going to wait until I get a tracker that is along the y-axis. So this one. And then I'll say set y-axis. And now that's aligned it over here. Let's go back now to the beginning. And we can see we've got this donut sticking to the floor. And I'm just going to look for a place where it goes a bit bonkers, where it starts sliding around. It seems to be working perfectly currently. And everything seems to be sticking quite nicely. And if this bothers you, by the way, this weird curly thing, that's the motion of the camera path. So just turn that off. So we're getting 0.91, which is still quite high. So what we can try and do now is we'll just make sure we untick these options, because these seem to be pretty good. And I'm going to delete this top one, so the one that's got the highest error rate. So click on that, X delete, and see if we can get a solver lower than 0.91 using the existing settings we've got over here. So solve camera motion. We've actually got 0.58 now. So if we play this back, let's go into full screen over here, go to first frame. It should be sticking perfectly, which it seems to be. That seems to be a really good result. Let's just look at the tracking markers. They should be getting smaller. These empties get smaller into the distance. Right, so let's grab this empty over here. We'll do Shift S, cursor to selected. And now let's just come out here, go to the first frame. I'm going to duplicate this donut. So Shift D, grab that, and I'm going to Shift S and say selection to cursor. And now if we go to the end, we should have got the donut now over there. Now, one thing you can see is the donut isn't sitting perfectly. It's sort of angled downwards a little bit. Now, this could actually be because the pavement itself is angled down towards the road, which it does appear to be. So what I'll do to fix that is one of two things. If it's just because the geometry, the actual pavement itself, or whatever you videoed, is angled down differently, then you can rotate the object itself until it looks right. You see now that's working pretty well. So I'll just put the timeline before that area. And play that back. The donut should be sticking pretty well. In fact, it's sticking perfectly. And again, we need to make sure that this donut is perfectly aligned with the center of the empty, which indicates where the actual floor was, so about there. And the donut is sticking perfectly. Now, if you ever find that if I just do Alt-R on this, for this instance, it does appear the pavement is downward slope, so this is correct. But if it wasn't, then it's most likely because of the same issue we had in the previous example, which was basically the 3 points on the pavement that we used to set the floor weren't completely flat, so it's become a little bit skew-whiffed. So sometimes you've got to manually adjust it yourself, and that's what we'll do now. Let's go back to frame 1. We'll press Shift-C to put the 3D cursor back at the world origin, over there. Now we'll choose the camera, we'll go back into camera view, go to the end, and I can rotate around the 3D cursor, so set this to 3D cursor. With the camera selected, we'll do R and Y, because we want to rotate the camera on the Y axis. And now we can actually rotate the world so that it seems to fit better, like that. Now we can bring this, let's just come out into this view. Make sure it's still aligned. Now we can bring it back down on here and back into camera view, and then that will fix that in the other instance. But for my instance, I think I was right the first time. Although maybe it was a little bit off. The floor, when we placed the floor, it could have been just not quite right. And that would explain that. So that's working fine, actually. I think that was probably the right scenario. Probably a bit of a combination of the two. But that's working fine. The donut's sticking over there. So that's a good track. Alright, so next up we'll look at the really difficult to track video footage. Right, so onto the really difficult to track footage, and this will give us the opportunity to look at some of the other tools and workflows that are available in the motion tracker. So I've already created the PNG sequence, and I'm just going to do from frame 134 onwards. I'll just check the range over here, so it's 278 frames, so I'll make sure I set the frame range to match that, 278. Put it into memory, so go to track panel, prefetch, blue line fills up to show it's moving into memory, and then it should play back nice and fast. So I'll have a quick look at the footage, and we'll go into full screen and play this back. So you can see already we've got a huge amount of motion blur where things are becoming really stretched out. Particularly when we come to this section, you can see things are just becoming a massive blur. So we do need to modify the settings that we've got over here. So we'll start off by choosing fast motion again. This is going to increase what we've got over here. Let's just see what this looks like. So control click, and it's given us a pattern size about this size. Now we can see already that this pattern is unrecognisable. And that's just because of the amount of motion blur. It's just becoming a blurry mess. So what we need to do is make sure this pattern size is big enough so that it also includes some surrounding features, some of the bigger features in the scene, like the roof and the windows. So it's not relying on those tiny little features like bricks and things. So we'll scale this up so the pattern area is a bit bigger. And then we'll bring that search radius down a bit. We don't particularly need it quite that large. And I'll right click and I'll do track settings as default. So now that's updated over here to make sure that all the trackers we place are of a similar, well, the same size and search area as this. So I'll just delete this tracker. Next setting we need to alter is the motion model. So we're going to try changing this to affine, but before I do that, I'll show you why we're going to change it. So let's come down to a point that is going to be getting quite badly stretched out. Let's say this plant here. So if I click on this, put a marker there, it's currently set to location and rotation. So this pattern area is only going to be detectable if it moves and rotates, not if it stretches. Now what's going to happen is, if you look over here, as I try and track this backwards, so I'll do Alt left arrow to go one frame at a time, the actual pattern is stretching over here, and that's going to make it more difficult to accurately track it. And if it keeps moving off screen, just click on the lock icon or press L on your keyboard, and then it will stay exactly in the middle. So you can see as I go forward, the motion blur gets greater. The yellow pattern, or the yellow flower, is actually stretching almost to the bounds now of the preview. So effectively the pattern is changing. And in order for the pattern not to change, what we want to do is stretch the actual pattern area so that it continues to look like the same pattern. And that's what affine's for. So let's go back to the first frame. If I change this motion model now, over here, because this is the settings for the current tracker, to affine, and we'll see the difference. If I track backwards, it will stretch much less in the pattern window because this box here, the pattern area, is actually changing shape to accommodate for the difference in size. So as that flower gets wider, the pattern area also gets wider. So it's getting smaller again, the boxes become smaller, and it's just trying to maintain that same pattern over here just to make it more easily recognisable so that you get more accuracy. So for this footage, we're definitely going to need affine because of the amount of stretching due to motion blur. So we'll change this over here to affine for the new ones. And then for the match, we also want to make sure this is on previous frame because the pattern will be changing quite significantly due to the amount of motion blur. So the pattern on the previous frame is most likely going to be a better match for the pattern on the current frame than the pattern was when we initially created the marker. So make sure that's on previous frame. We don't need normalize. Normalize is only used really if you've got a pattern that's going in and out of shaded areas. So I don't have that. I'm going to turn that off. And again, margin size, I want to make this at least 100 pixels because it always goes wrong at the side, I've found. And that should be pretty much everything we need. Correlation, I'm going to leave that quite low at 0.6, just so it's got more of a chance of continuing. And if it does make errors, we can spot those afterwards. Okay, so let's delete this tracker. We'll go back to the first frame. And similar to before, I want to make sure I don't put any trackers on moving parts. So we've got quite a lot of moving stuff in this one. It was quite a windy day. If we just zoom in and play back, you can see we've got quite a lot of movement on the thin branches in the wind. So definitely want to make sure we exclude all of that, including the trees in the background. The grass looks to be quite stable, but if you're not sure, just exclude it to be safe. I'm going to start off with the first method we used before, which is to use detect features. So I'm just going to use detect features and just going to put them all over the place. And let's zoom out a little bit. And then I'll just delete the trackers that are on the bits that could be moving, like the branches. And I'll select all these markers and I'll do track forward. If I just deselect them, or if I just hide the search in the screen, it's probably going to be a bit easier to spot. So let's turn that off. There we go. Makes them a little bit smaller. So E, track forward. I can already see a few problems that are happening. We've got trackers down at the bottom that say estimated. And this one here, you can see they're stuck on the screen and in a set position. So we're going to need to get rid of those. We'll just let it go as far as it can. So it's got to 229. It's actually gone quite a long way. If we come over here, we can come to the point in the dope sheet where it shows us we've got less than 8 trackers. So we'll come to here, and then we'll have a look. Make sure we turn off show disabled, just to make it a little bit easier to spot what's going on. So first thing, I want to make sure I get rid of these static estimated ones because they're going to cause problems basically. So we'll come across to the dope sheet and see what exactly is it that makes these estimated. So we'll click on one and we'll set the dope sheet to only show the selected tracker. And if we come across, we can actually see it appears that they only have one frame tracked. So one frame tracked is going to cause problems in the when we try and solve the camera. So I want to delete all of those. Now obviously we've got quite a few on the screen. I don't want to mess about having to manually select them all. So what I'll do, I'll come across to the solve options and we've got a section called cleanup. So under cleanup, we've got a few options now. We've got the clean tracks, which will do whatever we tell it to do in here. So we can either select them, delete them, or delete the segments. And then we've got the filter track. So this one, it finds any weird trackers. So if you've got any, come into the graph editor here, it'll look for anything in here that's got sort of a very strange pattern relative to the rest of the overall motion. And it will select those for us so we can choose what we want to do. But to start off with, I'm just going to select the ones that have got one frame, because as we can see, this is why they're estimated. So over here, we'll set the number of frames to 2. Anything that's got less than 2, it will select in the viewport. So we'll choose, make sure this is set to select, and I'll say clean tracks. And now it's going to have selected all the ones that are estimated, including the ones that are hidden as well. So if you've got the ones that are disabled, it will still be selecting those. So if I press X now to delete those, we'll see they've all disappeared from here, and now we're just left with the ones that have got decent tracking information. So let's just go again to the dope sheet and find the area where it turned red, which indicates there's insufficient trackers, less than 8. And then I'll go to a section where we've got a decent amount of trackers, where it's not too blurry. So about here. And I'm just going to manually add some more trackers now. So I'll just add the trackers using Control left click, making sure don't get them too close together because that will cause a real headache, and also making sure they're a fair distance away in the actual video footage as well, as that will help the solver to figure out the difference in movement and figure out, where they actually are in 3D space. So I'll just go through and add plenty of these to the scene in places I think would have a good pattern and where there's no movement. I'll try that. Then we'll track forward again. And if you watch the dope sheet background, you should see that the red part should disappear. So we'll do E, track forwards, and I'm just going to pause it after it's finished. So it's managed to get to 200. Let's just come back and notice this one here. Let's see what that one's doing. Where did that start? So that's the one that started on the bin. Now, obviously, when it gets to here, the bin is hidden, so it's sticking to this hedge. So I'll just find the last decent frame where it wasn't sliding all over the place. And I want to lock onto it now so that it's not moving around on the screen. So I'll click on this little lock icon here, making sure I've only got one enabled. And then as we drag the timeline, the box, the tracker, will stay center to the viewport. Now my Blender suddenly has become very unresponsive. So this is a bug actually in the tracking system. If you ever notice this, just restart Blender. That's what I'm going to do now, just to get the performance back. Alright, so bring that back in and hopefully it should start working. There we go, much more smoothly. So getting back to this tracker, to be honest, I don't think it's a very good tracker because it's the good information is actually so small, it's such a small range, I don't think it's worth having. So I'm just going to get rid of it. I think that's going to give us a better result in the end. So I'll just have a quick scrub through and look for any obvious problems. And we've got one here that doesn't look as though it lives very long, so we can probably get rid of that one. We'll just delete those. It appears to be only, I think, 2 frames. So yeah, we'll delete those. And I'll start adding more trackers just to get rid of any of these red areas or brown areas in the timeline. And then we'll track forward. So E, track forwards. Oh, I forgot to select the trackers, so we're only tracking that one. Let's just redo that. So select them all this time, and then we'll try again. E, track forwards. Alright, so we get to this point. We're nearly at the end of the animation in actual fact, so let's come to the end frame. and then we'll try and add some markers and track in the opposite direction. So make sure they're all selected. E, track markers backwards. Let's play this forward. And we can see, if we don't consider those estimated ones, it's quite sparse here. So I'll just add a few more. And then I'll select them all and track forwards. And if we just check the dope sheet now, we can check if we've got any red areas. But we're looking good. The only thing we've got are loads of these estimated ones, so we need to get rid of those. We'll use the same method as before. In the solve panel, we can use the clean options. Again, frames to clean tracks. And I can change this to delete if I want, and then clean tracks, and that will automatically get rid of them. Now we've still got in the dope sheet, it's reporting we've got no areas that are red. So that's good. It means we've definitely got 8 trackers at least on every frame, which is necessary. The more is probably better, but not if they're not very good quality trackers. It's better to have a few trackers that are really high quality than a lot of trackers that are awful. Otherwise, it's going to be a pain in the neck to try and fix at the end. So I'll do a solve and make sure I set my camera up properly for the iPhone 6S. I'll tick the keyframe option to let it choose the best keyframes, and we'll click on Solve Camera Motion. So we've actually got a surprisingly good error rate of 1.5. I mean, it's not perfect, but it's not too bad. So I'll turn off the keyframe option so it doesn't get overwritten, and then we'll turn on these options to see if these improve it any further. And you might find it makes it worse. 1.32. What was it before? 1.5. So it made it a little bit better. Try that again. Strangely, all I did was undo it. So Control Z to undo, and then redo it again, and I got an even better result. So that's a bit odd. Anyway, 1.21 is still not great. So there are going to be issues in here somewhere, and we want to be able to try and find those problems without going in and watching every single tracker. So if I go through all of these, however many trackers we've got, we could be here for a long time, which is not something I really want to do. So we've got a tool again in this cleanup area called Filter Tracks, which will help us to find any trackers that have got a strange movement. So I'm going to click on Filter Tracks, and it's going to tell us how many problems it's found. Now, 81 problems, that's way too much. I can't delete that many trackers, otherwise I'm probably not going to have any left. So I'm going to say F9 to bring up the options for that filter operator. I'm just going to increase this until it shows at the bottom there, instead of 81, I'm going to bring it down until it shows about, well, we'll bring it down until it shows 1 if we can. Keep bringing that back. There we go, we've got one problematic track, which is this one here, 52. So it selected it automatically. It should now be shown over here, and we can see when it starts. So we'll move the timeline to this, and we'll zoom in and have a look. And as we play it left and right, we can see it's actually moving a little bit on the pattern, so it's sliding around very slightly. And if these paths are too long that they're getting in the way, we can come into the clip display and just turn those down a bit. So I'll just move the timeline to find the place where it was good. I'll delete the dodgy data, delete that backwards. And let's see if that gives us a better solve. So that's taken it down a little bit to 1.11. And now I'll use the filter tool again to see if we can find another one that can be fixed up or removed. So it's found 2 tracks, but they actually look as though they've got really low error rates. In fact, the second one's got 0 error rate. So I think I'm going to leave these as they are, and we'll turn off in the dope sheet the option to show only the selected ones so we can see them all. So I'll click on the highest error rate, and we'll just have a quick look at what that's doing. And we can see it's actually sliding around on that hedge, so we'll just get rid of that one. Look at this one as well. It's quite short, so I'll just delete that one, I think. And then this one. This one seems to be okay initially, but then goes bad, so I'll just clear forwards from the last good point. So we've only got the good information. And we'll try and solve again. And now we're down to 0.74, which, considering the footage quality, is actually quite good. But I'm going to see if I can improve it further just by going through, looking at the really bad ones in the dope sheet and seeing if I can fix them or remove them. Now sometimes, rather than just deleting the bad data, we can actually try and delete it and then replace it with better data. And one way to do that is by changing the shape of the pattern area and then retracking. So I'll move the timeline to the last good area and then clear away the bad data. I can actually now modify this track if I want to. So let's try and expand this out a bit to get a bit more of this pattern area in it, to give it a better chance. We'll just have a quick check of the search area just to make sure it's still got plenty of space. Should be okay. And we can also try changing some of the settings that we've got over here. So that's fine, these are all fine. We could maybe try changing the correlation a little bit to say stop earlier if it goes wrong. So we'll try 0.75. So it's got to be more certain now that it's in the right place. But I think the main thing is going to be scaling it up, which should give it more of a chance. In fact, we could scale it a little bit further to get a bit more of that pattern area in. And now we can actually manually track forward. Now we need to make sure we get rid of any keyframes we've got forward. So I'm just going to press this again. Not sure why that appeared. Right, and now we're going to track forward manually using the Alt right arrow. So that's the same as doing it here, tracking forward one frame at a time, just so I can keep an eye on it and make sure it's staying pretty well stuck on. So Alt right arrow, and now we've got that bigger pattern area. I'm hoping it won't sort of slide too much to the left. And it's still not done the best job, I would say. So what I'll do instead is try tracking backwards from this point where it's in focus. And I'm going to clear backwards. And now I'm going to try tracking backwards instead. Let's see if that helps. So solve camera motion. And it's not made a massive difference, but I still think it's useful to know the technique. Another option we can try is actually reducing the influence of this on the solve. So we can come over here to the top. We've got the weight setting. So the weight setting is how much influence this will have when we come to solve the camera motion. So let's try turning this down to probably 0.3 and then try again. So solve camera motion. It's taking it down a little bit more. So we're getting slowly and slowly lower. So I'll continue finding and fixing the bad ones using either the dope sheet or the filter tool. And another technique we can use to manually fix a tracker is to actually place it by hand on each frame where it goes wrong. For example, this one we can see it sliding very slightly to the right. So I'll find the frame where it first starts sliding. So here, I'm going to manually put it back. And I can do it by looking in here as well. I'll move that back until it looks as though it's in the centre. We can do it over in this area if it's easier. And I'll go forward one frame at a time. Let's just expand this a bit. And I'll bring it into the middle each frame. And this will overwrite what the tracker's done. So I'll just repeatedly change frame and reposition it. You can see it did go off quite a bit, so that's why we're getting such a high error rate. But that information is still going to be useful if we can get it better. What we could try at this point now, because it seems to have, the motion blur has disappeared. Let's just get that in the middle. We can actually start it tracking again. So we'll use the Alt track forward. So Alt right arrow is going to track forward, and because we've replaced it now and corrected it, it should start doing a good job on its own. You can see it's sticking quite nicely there. So let's try and solve again. And although it's not had a big impact on the overall solving error, for that particular tracker, it's reduced its error rate from 0.69 to 0.44, which should make the 3D empties it creates much more accurate later. So let's see how effectively this translates to the 3D scene. And I've already got the 3D scene set up from the previous example, because I didn't start a new file, which is fine because the trackers in the 3D viewport would have been updated every time I click on the solve camera motion in the tracking editor. If you don't have that, just click on the setup tracking scene again like we did before. So let's go back to the beginning of the animation. Click on here. The donut's still in there thankfully, and the 3D cursor's at world origin. So I'm going to choose 3 markers on the floor. So a triangle. And I'll try and get one where the origin has got one directly in front of it, which it has there. So I'm going to choose this one, and then this one will be the origin. And I'll choose floor. So that's put, and then we'll set the orientation. So I'm going to choose this one now, which is directly in front, and I'll set this to be the y-axis, and that will flick over here. And I notice as well, I've not got the background set up in the camera. So come down to the background images. It's not added that in. So I'll just click on Set as Background, and that should put that in. You see that's now appeared in the camera. So let's have a look at full screen. Have a look. So it's sticking beautifully. Now, one thing you do need to look out for, it can be potentially indicate there's been a problem with the track, is if you've got smaller markers close up. So they should be bigger close to the camera, and then become smaller the further away from the camera. So if you look at this one here, I'll zoom in on that. That has been mistaken as being miles away. So it should be similar size to this one. And that can also be an indicator of an issue with the track. So something that could have been improved in the track. It basically means that this marker, the tracking marker, was moving in a way that indicated it was further away than it was. So let's have a look at it in the tracker and see what it's doing exactly. So it starts on the right hand side, and then it slides all the way across in a way that would be more fitting of a marker that's further away. So I'm going to remove the dodgy data again, ahead and behind this time. And then initially, I'll try increasing the pattern area so it's got a better chance of finding the pattern. So let's try again. I'll see if we can track backwards. So it's failing straight away in that direction because the marker is getting to the margin at the end of the screen. So I'll try tracking forward first, just to see if it works without having to manually do it, because I've changed the scale. And then I'll check it out in the graph, see what we've done, just to get it to show the currently selected tracker only. We can modify it in here, by the way. We zoom in, we can drag these individual points. So say I'm on, let's go back to a frame where it started drifting off. So it's in the middle perfectly, and now it's drifted off a bit, and we can actually see that represented in the graph. So if I choose this point, we can move that up. You see it's actually moving it over here as well. So I'll just continue manually correcting this on each frame. And let's try and solve that. So we're currently on 0.67. Didn't make a difference, but hopefully if we come across to the 3D viewport now, this is going to be the correct size. So there we are. So it's scaled it correctly now because it's not got sort of the wrong movement based on its location. So always keep an eye out for that, and it might improve your solve as well. So maybe this one as well should be bigger than this one. So I'll do the same for this, and then solve again. And it's not going to make necessarily a difference with the solve rate, but it is going to make sure that the 3D scene accurately represents the video footage, which of course is going to be very useful when you start using those 3D markers to help you add more 3D elements to the scene. And if we play this back now, we should be getting a quite good result with that error rate. And you've probably just noticed there's a slight judder in the 3D geometry. Now, that is actually correct. The judder is in the actual video footage, but it's more noticeable on the 3D geometry because the 3D geometry doesn't have any motion blur, whereas the video footage obviously does, so it gets smoothed out. Once we add the motion blur to the 3D geometry later, then that won't be noticeable. And I think we can call that a pretty decent result considering the quality of the footage. So with that, we'll move on to the next section where we put the actual robot into the scene.